This simulation is going to help us to understand what a buoyant force is. So the whole idea is that here you have a cement, and if you weigh it in air, it comes out to about 49 newtons. So pretty much 5 times 9.81 is going to give you 49 newtons. So that's the weight of this mass in air. Now if you place it in water, you notice that it weighs less. Here, and when we submerge it in water, it weighs 24 newtons. So it weighs less in water, but if you look at it, the weight arrow, the blue arrow, that's the object's weight. That's the force of gravity. That stays the same. So whether you're in air or you're in water, your weight is the weight of this cylinder of this piece of cement is going to be the same. So if this piece of cement, its weight, it's on the scale reads a lower reading, that must mean that there has to be another force here. So let's see what that force is. So in air, this thing is going to weigh 49 newtons. And if I submerge it in water, notice that as I submerge this thing in water, there's another arrow that appears. And this other arrow that appears is called the buoyant force. This is the force that water exerts upwards on that piece of cement, so that when you place it on the scale at the bottom, it weighs less. And the reason why is because of that purple arrow or that pink arrow pushing upwards. So that pink arrow that pushes upwards, that's the what's called the buoyant force, or the force of the water pushing upwards on that cylinder. And we can get an idea what a buoyant force does in terms of this piece of wood here. So the wood floats, and the reason why is because the buoyant force is able to it can be, in this case here, might be equal to gravity, or it might be a little bit more, but that force prevents it from floating. So in general, for objects that are low density, they float upwards, they don't sink. And what causes them to float is that, yes, gravity is pointing down, but there's another force that is pushing them upwards. So because this object here it's actually stable, it's not sinking or rising. The buoyant force is actually, or the force that the water exerts upwards, that's the pink arrow, is equal to this piece of wood, the weight of the piece of wood. For the piece of cement, though, the cement is more dense, so there it sinks. So now let's try to understand how to actually calculate the buoyant force. So let's just ignore gravity for now, and let's see what happens as you submerge this block into the water. As you submerge it into the water, you notice that the arrow, pink arrow, increases in length, so the buoyant force increases. Something else that increases is the part of the block that's submerged in the water. And you can see that on the right here. So the volume of this pool starts off at 100 liters. And as you submerge the cement into the water, that cement displaces some water away. And the amount by which the water rises, that corresponds to how much of the cylinder is submerged in the water. So here, the cylinder isn't submerged in the water, and here now we have the cylinder submerged in the water. So the amount of fluid that is displayed is actually 0.165 liters. And in here, this represents the entire volume of the cylinder, because the cylinder is completely submerged. So the volume of the cylinder is actually 2.5 liters. So this buoyant force, it depends on how much of this block is submerged in the water. If you have a small amount of the block submerged in water, in this case you're only 0.57 liters, then there's a small buoyant force. And as you increase the amount that's submerged in the water, the buoyant force increases. So here, let's see if we make it 2. Well, so here about 2 liters of volume of this cylinder, of this block is submerged in water, and the buoyant force increases. And if we completely submerge the block, then the volume that's submerged is equal to 2.5 liters, and that's going to be the biggest buoyant force. That's the maximum that it's going to get. So what a buoyant force is first the force that water exerts upwards on an object to make it float. So for example here, And that buoyant force, what it depends on is how much of an object is submerged in, or the volume of an object that's submerged in water. The bigger the volume that's submerged in water, the bigger the buoyant force. So the next thing that we're going to look at is, why do things float? So here, imagine that you have a tank with water. And then you have two objects. Let's say that you have a piece of wood, and then let's say that you have a piece of plastic, and they have the same size, and you drop them into the water. What you would observe, you can observe something like this. The wood sinks, but it doesn't sink all the way to the bottom. It floats somewhere in the middle. And the plastic, you drop it into the water, and it mostly floats on top of the water. A little bit is submerged, but not all of it. So how is it that this works? Well, what's happening is that, well, first of all, let's look at all the forces. Gravity is always acting down, which is why both of them, or they want to go down. But something else is acting on it to keep it from going all the way down to the bottom of the pool. And that other thing that's acting on it is the fact that the water itself is pushing upwards on those balls. So the force that the water exerts on the plastic here, we're going to call this the buoyant force. And the way that we're going to describe that is, let me just redraw this picture then. So let's look at that one in more detail. So you have your tank of water, and let's just imagine a general case where you drop an object into the water, and part of it is exposed in the air, but part of it is submerged in the water here. So the force that the water exerts to keep this object from sinking is going to be the buoyant force, and it's going to depend on the fact that you're in water, so it's going to depend on the density of water, but also it's going to depend on this section of the object here that's submerged in the water. So that's going to be the submerged volume. And from there, we're going to say that the buoyant force, FB, is going to equal the density of water times the volume that's submerged times G. And there's another way that we can look at buoyant force. So here, let's look at some simulations. So here you can see it. You have this green bar here. In air, it's going to weigh 20.6 newtons. And as I submerge it in water, more and more of this green bar gets submerged in water, which means that there's more water pushing upwards on it. There's more of a buoyant force. And you notice that now the weight changes to 13.9 newtons. So this is also a way that you can measure buoyant force. What you would do is measure the weight of the object in air and measure its weight submerged in water. And from that, you can calculate the buoyant force. So if you have an object that's in air, and its weight in air is going to be Fg in air, all you have to do is just get a glass of water or a tank of water, and then submerge that same object in the water, and you're going to measure the weight when it's submerged in water. And the difference between those two is going to be the buoyant force. So the buoyant force can also be written as the weight of an object in air minus the weight of an object in water.